Okay, so here I am, a very large head. Anyway, I'm going to use this for the first part of Unit 1 as my lecture. Um, the first part of Unit 1 is, and my notes will be posted in the Canvas as usual. The first part of Unit 1 is about language. So the most important thing, no matter what it is you're going to be doing, digging ditches, building rockets, playing music, whatever the case may be, the most important thing to learn about any new skill or craft is the language. You need to be able to talk to your peers. You need to be able to communicate clearly in the language of that culture, basically, right? So statistics, of course, is like that. It has its own language. And so we're going to be reviewing that for the next few minutes. I'm really just going to go through my notes fairly quickly. They're there for you to read. I know you know how to read. Hopefully I'll add something of value, but I can't promise you that either. But anyway, for the next few minutes, basically that's what I'm going to do. So I'll share my screen and talk about my notes. If I can find my own copy. There we go. All right, so here we go. This is the first 4 sections, I think, of Unit 1. Actually, the first 5. No, I'm sorry. That's not true. The 5 and 6, I believe I did in a different lecture, and we'll connect you to that too. You'll see all this posted. You'll get directions, right? You'll look at my YouTube channel where the rest of the lecture for Unit 1 is, okay? So here we go. Let me share the screen, right? First thing we want to do, let me pull up my notes. Let's see what we can do. All right, so basically, right, we do this all the time. Oh, this is, the sky is blue. Well, that's probably not a good thing. Let's see. Everybody's on Facebook, right? Because everybody I know is on Facebook, because I know everybody talks about Facebook, everything. So everybody's on Facebook. Well, that's what we call anecdotal knowledge, right? Everybody likes fruit. Everybody likes cherries, whatever. Because everybody I know likes cherries, I make that observation, but that's all it is an observation. It's not actual research. And so it's what we call anecdotal knowledge. And people use it and say it all the time. And oftentimes it can be true, but oftentimes it's not, right? You know, it goes back to, I remember when I was teaching psychology and studying psychology, it's like, well, it's just common sense. Well, if it was that true, then we'd all be a lot better off. Anyway, so anecdotal is just our observations. There's no real evidence or proof that what we're saying is true, okay? So to get some proof, to get evidence, to get something to back up our claim, right? We have what we call the scientific method. And this is how we develop experiments and develop research and work to prove what we're saying has some validity. So the same thing in the scientific method, you make observations. So, you know, I think everybody likes cherries, right? And so that's what I just said, right? So by saying that, I created my hypothesis. I made the observation that all the people that I'm looking at like cherries. And then I decided my hypothesis is everybody likes cherries. And then what I do is I start to collect data to challenge my hypothesis. I want to prove myself wrong. And conversely, if I can't do that, then I can prove myself right, which is a a relative term, because we never typically say we're 100% sure all the time. Anyway, we'll get into all of that later, right? Anyway, so then I would collect data, which means I would go out and do a survey. And instead of just looking at the people around me who are eating cherries, I would get a bigger group, right, to ask how much they like cherries. On a scale of 1 to 10, how much do you like cherries? Then I would collect all that and all those numbers, and I would interpret that data. And from that, then I would decide whether or not my hypothesis of everybody liking cherries was true, right? And that would be based on the scores, right? So if I say, like, how much do you like cherries, 0 to 1, we're going to get into this a lot. 0 being not at all, and 10 being the best. You know, I love them. I eat them every day. Based on where all the scores end, the most scores are, all of that, then we'll decide whether it's true that people actually like cherries or they don't. Right? And then I would use that to say I was right or wrong about my hypothesis. Okay. So there's 2 ways to go about talking to people. There's qualitative questions, which are open-ended questions, where you don't really you can't put a numerical value to it, let's say, right? And can you tell me why you like cherries? Well, everybody would say something different, right? I like it because they're juicy. I like it because of the texture. I like it because they're tart. I like them. So everybody could say something entirely different, and I would end up with a bunch of information that I couldn't actually interpret, right? Or it wouldn't really give me a whole lot because it's too much and it's nothing alike, right? I could look at say how many people said use the word tart, but I might not ever, it might only be one person, right? So we like to be able to assign a numerical value to something because numbers are what we can manipulate, and because this is a math class, obviously we're going to be dealing with numbers, right? A math class of sorts. Anyway, right, so qualitative, oh, that's wrong. See, I got to fix this. So quantitative is, let me see, can I edit this now? Quantitative. See, thank you. Caught my own thing. Quantitative data is something we can assign a numerical value to. So like I said, tell me how much you like cherries on a scale of 1 to 10, which is what we call a Likert scale, Likert. And we use those a lot. And you've seen them. You should be more than familiar with them, right? All right. So then we, like I said, we collect data and we interpret data. You have to be very careful. We're human beings, and we often want things to work out in our favor, right? And so data can be interpreted in many ways, and unless you're very objective about it, you can make it say what you want, like people do. A lot of people make data say what they want. You only present a piece that works for you. There's a lot of different ways to go about that. But you just have to be careful and present the honest truth, whether you're right or wrong. Right? And oftentimes we're wrong. Like a lot of hypotheses prove to be wrong. It's okay. But now we know for sure that it's not true, right? At least we learned something. All right. So variability, right? It's how much do those scores change? Like how much do they differ? So on that scale of 1 to 10, right? Did everybody lean towards the 10s? Did I get a lot of zeros? Did I get the same amount of zeros or ones as I did 9s and 10s? Then you're going to learn. Most people probably end up in the middle. The majority of scores typically end up in the 4, 5, and 6 range, but we'll talk about that later too. But a lot of times. But the variability, how many people said what score or received what score, right? It could be an exam, it could be other things. All right. So the variability, how much do things vary? How much do things differ? Descriptive statistics, summarize statistics, summarize the data, and give us a more concise thing than a data set. So your data set is just your bunch of scores, right? Once we manipulate and put that scores and start interpreting them, then that becomes inferential, descriptive statistics, right? As opposed to inferential statistics, which indicate how confident am I, right? So I can't ask everybody if they like cherries. So I have to ask a sample of people, right? And if they like cherries. I can't possibly get everybody to answer it or to be there. So I get a sample of people, and then how confident I am then from that sample and that data, am I confident enough, how confident am I to be able to say it applies to the rest of the people, right? So inferential, how do I infer from this data, how confident I am that I can infer from this little group of people that it applies to a bigger group of people. And we're gonna talk about all of this stuff again. I'm just running through this, right? All right. So the margin of error gives me the quantifiable measure, how much error is possible in the data. So you've probably seen this, read it, you've read books, you've read things where somewhere it'll say a statement and then it says plus or minus 3%, plus or minus 1.5, plus or minus 5. That's your margin of error. Like if I say, when I asked everybody and gathered the data, 7 was the standard score. 7 was the average score for how people like cherries, plus or minus 1%. So I could be wrong, and it could be 6, it could be 8. I'm saying it's in that range somewhere, okay? The margin of error. A population is any group in which a researcher is interested. So I define, whatever I define that as, I could say it's every college student in the world. I could say it's every college student in Stockton. I could say it's every student at Delta College, or I could just say it's every student in this class. I define it as I want. Then, however, a sample is a subset of that population, right? So obviously, if I wanted to, I couldn't talk to every, I probably wouldn't be able to do research with every Delta College student, right? So I would take a sample, a subset of that of every student. So I could take one person from every class. I could take this class. It wouldn't be a very good sample, but it's a sample of Delta College students. And we'll talk about the goodness of samples and what that means later, okay? So then census is when all the members of the population are included. And right now, I hope you're aware, it is this 2020 census that we do it every 10 years, and we try to get information. The government tries to get information from everybody in the country. For a variety of reasons, but we want to know how many people are in the country actually, right? What's the census? What's the number of people? And then from that, where they are and different things, and we use that information to disperse resources, etc. Right? But the census is everybody in that population. So going back, if I said it's every student at Delta College, that means every student that's a registered, certified, registered student at Delta College. Okay. Parameters, percentages when discussing ascendance. So parameters come from a census or population, right? When we're dealing with an entire population, which is rare, but when we do, we call those parameters. Statistics, which is what we're mostly going to be dealing with, is what we call it when we're just using a sample of that population. All right? All right, moving on. Let's see, scales of measure. All right, so we measure things in different ways, right? Of course, we can measure things in inches, feet. We measure things in seconds, minutes, like all kinds of things. But we also measure things on a much different basis, right? So and then how do we, what's appropriate for the questions we're asking, right? So nominal data, what we call nominal data, categorical, means it's just it. It's a category. You're a Republican, you're a Democrat, you're male, you're female, you speak English or you don't speak English, anything like that, right? You're in this group or you're not in that group. It's just that, all right? So now, then the next level up is ordinal data, right? So it puts things in order, but there's no value. One thing is still not any more valuable or has no quantifiable difference than the other. So you, right, let's see. So tall, medium, short, right? We can put people in. That's probably not that good because there's a definition for those things, right? So let's see, what was I thinking? Order, so, well, I can do that. Red, white, and blue. Green, yellow, and pink. Which color do you like? What's your favorite color? All right. So there's an order, but it has no rank. Pink, I'm not saying red is better than blue or pink is better than yellow or anything like that, right? That's a real simple one, right? You pick the one. Now, intervals tell me that there is a steady measure between them. So there is a value, right? Let's see. 1 apple, 2 apples, probably not the best. Let's go back to that, right? So by height, right? So I want you to go from shortest to tallest. And then I know, and I say tall, right? Because inches and feet, nothing is 0 inches tall, right? If something is 0 inches long, it doesn't exist. So, but those are relative things that we just decided. This is an inch, this is 2 inches, this is a foot is 12 inches, right? There's a system we made up, but it gives somebody a rank. The scores on your exam give you a rank, right? And we're going to talk about this a lot more, right? And so then there's the intervals, right? 1 foot, 2 foot, 3 foot. Now, ratio is the same thing, but then there's an absolute 0 defined, right? Temperatures too, right? So we know our intervals, we know a degree is Celsius or whatever, right? But it's just arbitrary. We decided what 0 is. When there's an absolute 0, it's then called ratio. And our author in his Defined Wisdoms, no oil in the river is nominal, ordinal, interval, and ratio. And like I said, we're going to be working on all of this more as we go on. All right, section 3, and I think this is the end of my lecture here. Frequency. So how many times does something happen? It says here number of individuals or cases. So if I said on a scale of 0 to 10, how much do you like cherries? How many people said 7? What is the frequency of the score of 7? How many people said that? What is the frequency of 4? And then is the total number of cases. And then the percentages. We work a lot in percentages because this is wrong. Percentages help us compare groups of different sizes because a lot of times we want to compare groups and we can't always make 10 people in a group or 20 people in every group. Groups have different sizes, and so percentages help us work around that difference. Okay? And then proportion, of course, is how many out of 100. And of course, it's directly related to percentages. So these are some of the definitions. The rest of these definitions are in my the second part of the lecture for Unit 1, and that's on a Zoom, and that's on YouTube in a different format, and where I'm actually using the whiteboard to demonstrate some of this stuff. So you got the notes, you got this, hope it helped. And of course, I'm available for questions and office hours. All right, good luck, thanks. All right, good evening. At least it's evening here for me. I don't know when you're watching it, but this is the first of how the rest of the semester is going to look. I'm going to be lecturing just like you were sitting in the classroom here. I'm going to do my best to cover my material. Up until now, you just got some lecture notes about definitions and things, but now we're moving into things that I believe require a little more demonstration. So we're going to do this, and like I said, I'm going to lecture from here on out just like you were sitting in the classroom. I'm going to go through the material in the book, and we'll add some other problems, but mostly I'd like to try to follow the book so that you have a reference to go to outside of class, and you don't necessarily have to be taking notes all the time. So this is section 4, Introduction to Frequency Distributions, right? So this is the first thing we're doing. Statisticians, we love tables. Like, that's our thing. We put everything into a table. We organize our data in tables, and this is the first and most simplest table, right? So the frequency distribution, we talked about the frequency, how many people got what score, right? So the tables start, of course, with the lowest score on the bottom and going upwards to the highest score. And then corresponding, how many people got each score, right? One got 24, one got 25, nobody got 26 or 27. Two got 28, 29, and on so. This particular table is, this particular set of data is actually skewed, and we'll talk about that a lot more later. But what that means is there's a lot of people that scored very high on the and so got high marks. The biggest number of people are in the higher marks. So this is it. This is how we do the tables. We number our tables. We put a description of the table there, what this means, right? So this table is the basic math scores for college students, and whatever these scores range from 24 to 37, and the number of people, and the total number of people that we got, 33, right? So this is how we present our data, and there's a list of rules, and I will post them in my lecture notes for this in Canvas, so you will have some reference to go back to, but basically this is it. And we're going to keep expanding on this to include more and more information as we go on. Another way to present the same type of data is to do when we do group data. So if here we only had right from 24 to 37, so basically there was only 13 scores to list. If you were going from, say, 0 to 50, you wouldn't want to put a column of 50 separate numbers, so we group scores. And we group scores in 3s or 5s. So basically we group, well, we're going to do a group score, and you'll see the example. It's 6 to 8, so 6, 7, 8, right? 3 numbers. 9, 10, 11, 12, 13, 14. That's the grouping of 3s, right? Same thing, if we did 0, 1, 2, 3, 4, and then 5, 6, 7, 8, 9, that would be the grouping of 5s. Basically, and we keep them in odd numbers like that, right? So I'm going to set up another table, and you can look at it. So as I said, oftentimes you have a span of scores that's much larger than our previous example, and we have to do score groupings, otherwise our tables would be unmanageable, which they get to be anyway sometimes. However,
So in this example, right, the scores range from the lowest of 6 to the highest of 41. And we don't, that's actually a number of 35 separate scores, right? So we don't want a column of 35 individual scores, so we do the groupings. We do intervals, right? And in this case, as I said, we're doing intervals of 3, 6, 7, 8, 9, 10, 11, 15, 16, 17, 24, 25, 26, etc., right? So that's what we're doing. And then we have the same thing. We use our frequencies and we stack our frequencies, right? 4 people got between 15 and 17. It's not a very good thing. I recommend this all the time. You need to keep your tables as neat and in line as possible because they just get more complicated and you make mistakes because you're not in the right column or your columns are going sideways and all kinds of things happen. A lot of people even use graph paper just to make their tables. However, that's not necessary, but I'm just warning you, it's best to keep them as neat as possible. Right, so here we are, 5 people. This is a much more evenly distributed scores, right? This is much more, most of the people are in the middle, which is typical, and less on the fringe, right? So here we go, and here now we said the sum of F, right? The sum of the frequencies is 34. That's the same as N. Right, it's the total number of subjects, the total number of scores, right? So the sum of the frequencies is the same as N. And that's how we just do it with the grouping. It's the same thing, the same rules apply. We number the table, we put our description up, and we label our columns across the top, okay? Now, we're going to add percentages, okay? So the next column we're going to add to the table is percentages. So we want to know what percentage of people scored between 39 and 41. What percentage of people scored between 18 and 20, right? And we went over how to get the percentage in the first actual lesson where we did the basic math review, right? You take to get the percentage, you take the number of subjects, right, divided by the total number of subjects, right, and then you multiply by 100. That's how we do it, right? Very simple. So, in this case, we started and we did our column of percentages. We label it P, and here it is. One person is equal to 2.9%. 4 got between 15 and 17, and that's 11.8%. And these were rounded down, right? These were rounded numbers from your calculator, because of course your calculator gives you many more decimal points. Round before you multiply by 100. Now we're going to start doing some, adding some more, right? We're going to just keep adding columns. That's the way it goes. Like I said, as the tables get more and more complex, the more and more data we do. So now we're going to look at what we call the cumulative frequencies. How does the frequency add up, right? We're going to start at the bottom here. And this is like climbing a ladder. I show you the pattern, right? I'm going to start here with 1. I'm going to go back to the frequency column and add the next number, right? So 1 plus 1 is 2, 2 plus 0 is 2, 2 plus 4 is 6, 6 plus 7 is 13, 13 and 6 is 19, 19 and 5 is 24, 24 plus 5 is 29, 29 and 3 is 32, plus 0 is 32, plus 1 is 33, and plus 1 is 34. And here is the checkpoint. If your cumulative frequency at the top of this column does not equal your cumulative frequency, your sum of frequencies at the bottom, you made a mistake someplace, right? Your cumulative frequency total should equal n. If it doesn't, you made a mistake, but that's your checkpoint. If it's not right, it's not right, okay? So this is how we do cumulative frequencies. I will do that a lot because my handwriting is terrible. Oh, we're also going to do the same thing with cumulative percentages. Right? And it's the same pattern. Right? So cumulative percentage, or cumulative P, works the same way. I have 2.9, right? I start with plus, then I go and add. Plus 2.9 is 5.8. And you guys can check me because I'm doing this in my head. Plus 0 is 5.8. Plus 11.8 is 17.6. Right? Plus 20.6 is 38.2. Plus 17. Oh, I actually have it written down, so I don't have to do it in my head. Plus 17, right? I keep doing the pattern. Plus 17.6. Plus 55.8. And so on. Plus 14.7. Plus 14.7. Plus 8.8. Plus 0. Plus 2.9. Plus 2.9. And here, I should always be at 100%, right? Now, due to rounding and those things, we may not always hit 100%, and here I got 99.8, right? But that's close enough to let me know I didn't make any mistakes. If this was 89%, I'd have a problem, right? But as long as this is close, within a few tenths of 100%, then you're pretty safe that you did it correctly, right? And those are rounding issues, and those will come up a lot during the class, okay? So, this is how we are doing our tables, and now we're going to introduce a new term called percentile rank. So, you may have heard people say they're in the 98th percentile. They're in the 75th percentile. But what does that mean? Right? So what that means is, if I say somebody in this grouping is in the 97th percentile, what I'm talking about is everybody below them scored, everybody below them scored less than 97. They basically scored 97. And in this case, in our table, it would be 96.9. And they're in the 96.9 percentile. And everybody else scored below them. That's why most people want to be in the 98 or above. You want to be in the top, right, ranking, not in the bottom, right? So we'll talk a lot more about percentile rank later. But when you hear that term, that's what that means. Where are you in this column of cumulative percentages? The 70 percentile, right here, right? People that scored 24, people that scored between 24 and 26 are in the 70 percentile. So here we are, that's the percentile rank. When you look at people, or people tell you whether they have their own percentile rank, you'll know what they mean. And this brings us to the end of Unit 1. So this is it. That was the end of Section 6, and we are done with Unit 1. You will have an exam, right? You have your worksheet to practice on. You have your project to do, and then we'll have an exam, and we'll move on to Unit 2. And feel free to email me with questions, or come to office hours, or Zoom office hours, and I can answer any questions or run through anything you need me to do again. Okay?